All right, so we're looking at section 3.2, which looks like this. Oh, whoops. Oh, I don't know what I just did. Hold on. Goodness gracious, where'd it go? Don't look. All right, here we go, section 3.2. So we're starting here with domain and range of a relation. So a relation is just a set of ordered pairs, lots of different ways it can be written. But the first values, which are usually x's, but the x values represent the domain. So, oops. So the domain here is the -5. Well, it's -5 in all of them. So domain is just -5. The range is the y values. So it looks like we have 5, 6, 7, and 8. So 5, 6, 7, and 8. Now then it asks if it's a function. A function has the property that every x in the domain has exactly 1. So that's the key, exactly 1 y value. So by exactly 1, there can't be more than 1, obviously. But there also has to be at least 1. So looking for exactly 1. So notice in this case, if I asked you where -5 went, the first person might say, oh, it goes to 8. And then someone else might say, oh, no, it goes to 7. Oh, wait, it goes to 6. Oh, wait, it goes to 5. So because -5 goes to so many places, this is not a function. The x values have to go to exactly 1 y value, which means if I throw out any value in the domain, everyone has to agree on what it's paired with. In this case, we have 4 disagreements on what -5 is paired with. So for the domain, we're just going to put in -5. And for the range, I always like to do these in order, 5, comma. Make sure you use commas to separate. And again, this is definitely not a function. And let's look at the next one. Same exact question, so I'm just going to skip it. Notice this one. Oh, it's practically the same exact question. All right. Oh, did it not actually go to question number 2? Is this question number 3? Oh, question 2 and 3 are the same. Let's see what question 4 is. All right. Let me just make sure that that was, yep. All right. So now question number. So this one, they told me it's a function right off the bat. This is called a piecewise function. This means that it gives you a rule and then tells you when to use it. So this one says, here's when you use the particular rule. So if you're going to plug in, let's say I wanted to know what -2 was paired with, first you'd look here to see which rule to use. So it says when x is less than 0, you should use the top one. And -2 is less than 0. So if I asked what -2 got paired with, that's what this notation means, I would plug it in to that first one. And -12 plus 10 is -2. However, if I asked you about 5, well, 5 fits with greater than 0, which means if I were going to try to figure out what 5 gets paired to, I would use the second rule. So 6 times 5 plus 20, which would be 50. So that's what a piecewise function does. So funny, I just made those up, and I should have just done the ones they asked me to. So -1 would go in the first one. So that would be -6 plus 10, which is 4. A 0 would go, notice that would go in the second one. So that would be a 20. And then a 2 would also go in the second one, and you would get 12 plus 20, which is 32. So this part at the end tells you, so match your x with one of these parts at the end, and that's going to tell you which rule to use. So again, the -1, we put into the first one and 4. The 0, we plugged into the second one and got 20. And the 2 we also plugged into the second one and got 32. All right, let's look at question number 5. So this one is a piecewise function like last time, but they want me, so they're telling me what the pieces are, and they want me to figure out what the rule is. Now notice these are all straight lines, and we learned in chapter 2 how to find the equation of lines. So let's look at this one and try to find his equation. So it's got 2 points, pretty brazen on there. The point -6, -1 is that blue one here. And then the other one is -1, 4. So here's 2 points. And again, how do I find the equation of a line with 2 points? Well, we did this last section or last chapter. So first I'll just find slope. And you could actually count out slope if you wanted to. But that would be change in y, which would be 5, over change in x, which would be what, -7? So change in the y values from -1 up to 4 would be 5. And then the change in the x values, we're going from, oh, I thought it looked a little funny. That's a -6, you guys. So -6, -1. So how do you get from -6 to -1? You go up 5. So the slope here is 1. Yay. All right, so the equation of this line, we do y minus, now remember the equation here is y minus y1 equals m times x minus x1. So we're plugging in for this, the x1, the y1, and the m. You can pick either point you want. I'm just going to pick that point. So y minus 4 equals m times x minus -1. So in other words, y minus 4 equals x plus 1. And then we'll add the 4 to both sides. And we'll get that y is equal to x plus 5. So this first one is going to be x plus 5. So that's what we're going to put in here. Now remember, this f of x is the same thing as y. So we're just going to put an x plus 5 in for the first one. So that's saying between -6 and -1, we're going to use this line. And what is that line? X plus 5. Okay, so now when we're between -1 and 2, we're going to use this line. So I need the equation of that line. Well, that's a horizontal line at 3. So remember, that's just equals 3. All right, and so now it says that when x is between 2 and 6, we're supposed to use this line. So now I've got to come in and find the equation of the. So let's see if we can find the equation of that line. We'll do the same thing we did for that first one. So let's find 2 good points on there. Let's see, we've got the point 2, 2. And, oh, there's not another kind of exact point, is there? I don't know. That one? Does that look like 4, -3? I don't really like that. We should have another nice exact one, but I mean, that looks pretty good. Over 4, down 3. So my slope then, change in y, well, from 2 to -3, you go down 5. And then from 2 over to 4, you go over 2. So the slope here is 5 halves, so drop 5, run 2. So now we're just going to pick one of them. I'm going to pick the first one and plug it into that equation. So y minus the y value equals m times x minus the x value. So that means that y minus 2 is equal to -5 halves x. Notice that's just plus 5. We're distributing this. So the negatives turn into a positive, and then the 2's cancel out or divide out. And then we add 2 to both sides. So we get y equals -5 halves x plus 7. Now I'm a little wary of this one just because I kind of had to guess at a second point. Let's see what happens. So we're going to have x plus 5 and then 3, and then we're going to go with -5 halves x plus 7. -5 halves x plus 7. -5 halves x plus 7. one, it's 3. And for this one, it was what, x plus 5? All right, let's see. Yay, we got it. All right, so perfect. So again, I was just a little nervous about that last one, but I guess looking at it, I mean, that looks pretty good that it looks like the point 4, -3. So just be careful. This one is not on the line, so make sure you don't pick one there. All right, let's look at the next one. So this is just like the last one. Actually very, very similar. So find the equation of this line. That's what you use when you're between -6 and -2. The equation of this line is y equals 3 again. And then the equation of this line, notice the slope here. It's actually a bit of a funny, well, you can use that half point, but it looks like that one's actually on the, at what, 5, 1. So you could use the point 3, 2 and the point 5, 1. You can use the half if you want as well. But so that's just like the last one. All right, so here this time we're going to do the graphing. So they're giving us the rules and we're going to graph. Now these are all going to be lines, line segments. Well, actually look at this first one. So the first one says that x is less than or equal to -1. And it says if you're over there, so I'm going to kind of, here's the breakup points. So to the left of this, I'm going to use this first equation. And it says -1. Well, that's just a horizontal line like this. Now notice it's going to go on forever. So I'm going to put a little arrow. Also notice it has the line underneath, which means it's including -1. All right, so that's the first one, check. For the second one, this is the equation of the line. And notice that it's a linear equation. It has a y-intercept of 1, and it has a slope of 2 over 1. So if we start at the y-intercept, which is 1, we're going to go up 2 and over 1, and then connect those dots. But now it's to only use that when x is between -1 and 1. So let's go down 2 and over 1. So we actually have an open circle right here because, see, it doesn't include it. And then we're going to go up to here, and this is going to be a closed circle because we are including it. So that's that one. All right, and now for the last one, this is another horizontal line. Notice it does not include 1. So we have a horizontal line at 2, but it's an open circle here. It's not including it. You see, it doesn't have the line under it. And then, so let's go ahead and see if we can put these answers in. It says here in the bottom, be sure to include closed or open dots at your breaks in the graph. So the first one, I'm going to choose this one because remember we had an arrow. It goes all the way to the left. But on the right, it started right here, right? No, -1. And then it just goes on forever. So notice that one's making it go on forever. So this option has a starting point, but it goes on forever. And I do want a solid dot there because it is including. So I don't know if I need to actually, here, I'm going to go ahead and put it there. So right here, I want a closed dot. So I went ahead and closed dot because it includes that. All right, now let's look at this second one. The second one, remember, is just a segment. It crossed the axis at 1 and had a slope of 2. So down 2 over 1. So it really starts here. And let's see, up 2 over 1, up 2 over 1. And I'm going to stop there because it says just when x is between -1 and 1. So now technically there was an open dot here, but we already have a closed dot. On this side, we want a closed dot. Okay, so it was open on the left, but it met up with that one, so there's not actually a hole there. On the right side, I want that include. Now for the last one, this is when x is greater than 1, so that means it's going to go on forever in the right to the right, and the line is 2. So we use this. So it's a horizontal line from 2 to, well, for So that's the 2 part. And then I want to make sure that it's only good for x greater than 1, which means I don't want to actually include this point. You see, it says strictly greater. So there's our final answer. Looking all pretty. It got mad at me. I wonder if it's because of that open circle. Oh, it doesn't say. Huh. But it's got, you see how it's got this one highlighted? So I'm guessing we needed to put the open circle in there, which doesn't make much sense to me to put an open circle over a closed circle. But let's do another one. So for this one, we've got the horizontal line when we're less than or equal to -1. So again, this one goes on forever to the left. So I'm going to select this one. And it's going to start when x is -1 and go this way forever. And it is going to include that one. So I'm going to put a nice circle on there. That was my less than or equal to -1. All right, when I'm between -1 and 1, is this the same one as last time? Oh, it's just weird. Okay, well, look, we're doing it again then. So this one crosses the axis at 1 and has a slope of 2. So we're going to go crosses at 1. We're going to go up 2 and over 1. So down 2 over 1, down 2 over 1. Looks like that. But now I guess, so this time I'm going to go ahead and put an open circle at the end of that and a closed circle at the other end. Yeah, but see, now it's got a hole there. We don't actually want a hole there. So never mind, I'm putting this back. Oh, is it going to let me put it back? Oh, I guess, do I have to undo it? Oh, there's my dot. So let's just put the dot back. Well, I guess it's under there. This is just kind of strange. But okay, let's do the last one. That one goes on forever. Oh, look, it came back. Perfect. Okay, so I did put the open circle. And then it looked like it got rid of my closed circle. But the closed circle was still underneath there. So, all right. So now we want the horizontal line at 2 when x is greater than 1. So from here over, we want this line. And we want an open circle on the end of that because we're not including that. All right, so let's see if it likes it this time. Oh, I think it took off for the same again. So it's kind of strange. Oh, you know what? Let's read the directions more closely, you guys. Only at breaks in the graph. So we don't need to put anything if there's no break. So that's why we have funkiness. So let's see if there's one more to do. All right, so let's look at this one. We are only going to put an open or closed circle if there's a break. So what we'll do is we'll graph all of them, then we'll go back and figure out if we need to put open or closed circles. So on this one, we're starting with, notice this is going to go on forever because it's everything less than. So that's this one. It's going to be at 3, but it's only good when x is less than or equal to 2. So here's the 2. So I'm going to go up 3 and then over forever. Okay, so there's that horizontal line. When you're less than or equal to -2, you want to be 3. This middle one is going to be a segment, and it's -x plus 1. So that crosses the axis at 1 and has a slope of -1. So that's down and over. Now we want this one, oh, well, till we get right there, right? So we're doing this one for x between -2 and 1. So we're at 1 for our line, slope of -1. So down and over. So that's our starting point. So now let's go up and over, up and over, up and over. Oh, and it goes right there, doesn't it? So from -2 to 1, we're on that line. Notice it has a slope of -1, crosses the axis at 1. All right, so now for this last one, this is a horizontal line, but it goes on forever. So I'm going to pick this guy, and it's at 2. So when x is 1, we're starting. So that's right here. And we're going to go over forever. All right, now I'm going to go back and I'm going to put my closed or open dots, but only at breaks in the graph. So I only need 2, one here and one here. So notice at the end of this slant, if you look right here, we do want to include that. So I'm going to put an inclusion there. However, this second one, we're only on that horizontal line if we're strictly greater than, so we're going to put an open circle there. There we go. So hopefully you watch this whole video so that you can see that we figured it out. So if there's no break in the graph, don't put anything. Yay, we got it. All right, so that is our 3.2.